screen one. All right. Are you able to see, because this is blocking my screen, so are you able to see something like a notepad or kind of thing?
Yes.
Yes.
Okay. Yes. All right. As I said that, for me,
I'm in a class.
and
Director, can you mute, please?
so here we have, we'll start with this concept. I will come to this at the end of it, because this is really very straightforward, and you really want to this is more of a rote learning in terms of we need to understand what is ordinal, what is nominal, and all those things. But that's very straightforward. So we'll come to it once we have done this part. This is very important from the point of view of all the stuff that you'll be covering later on. I'm talking about chapter 5 to 7. And this, once you are familiar with probability concepts and conditional probability, which is what I think you will be probably questioned most from the probability part, and that affects a lot of understanding later on. So we'll get started with that. Someone also had mentioned to me that we should I should talk about probability more. But if you have any other questions, feel free to interrupt me. Right? I will not. I don't want to stick to a particular thing, and this is very new for me. Right? I am just sharing what I know. I could be wrong. I could be right. But I will try my best to explain. We'll start with probability, and this is what probability typically is. And if you have any questions, even very basic questions, that's absolutely all right. Feel free. We can have as many sessions. As I said, because I'm studying from my MTech, I really don't mind it. It furthers my own understanding also. So feel free to ask those questions, right? So probability of an event, and I'm assuming everyone is, someone is taking care of the joining and all those things, and the WhatsApp if someone wants to join. So probability of an event we know is always less than equal to 1, right? And it lies between 0 to 1, right? There are, when you have two events A and B, then those events may be independent, mutually independent, or they may not be. So if they're mutually independent, they might be something like this. And for example, it could be that probability that it's a Tuesday. Can you tell me what is the probability that it's a Tuesday?
1/7.
Absolutely.
1/7.
Yeah. And let's say that it's gonna rain, right? So some probability with rain, but these are mutually exclusive events, right? And they are independent also. Mutually exclusive and independent are two different things. When they are not disjoint, so this is the case when it is not disjoint. These are some of the important things, because I know where people get confused most often. And so my idea is I will actually work some problems with you, reinforcing the concept, so that when we practice it, it becomes easier for you. So this is not disjoint. Sorry, this is not disjoint, and this is disjoint, right? In not disjoint, you have P of A union B. If you want me to go even more basic, please ask me to do that. I will do that. Is nothing but P of A plus P of B minus P of A intersection B. Anyone can tell me why there is a minus here?
Because
That is the common point.
because it is being used two times.
It is already.
One is common actually.
Yes, it is because it is being added two times, right? It is part of A as well as it is part of B, not because it is common, right? So P of A is using this, so you have this part, and then you have this part, and it is getting added twice. I hope everyone is clear with that.
Yes.
What happens when it's a disjoint is that there is no intersection and this goes away, right? I'm obviously using wrong ink. I should be using red for crossing and this. But so P of A union B for a disjoint one is P of A plus P of B, right? Are we clear with this so far?
Yes.
Is there a question?
No, Anup, can you please repeat that?
Okay. So what I was saying was, if the events are disjoint events, right? The events are disjoint events. That means they are not intersecting at all, right? Then P of A union B is simply the sum of their probabilities, which is which is P of A plus P of B.
Yes.
Okay. The reason is because in this case there is no intersection. Whereas if they are not disjoint, then P of A union B is equal to P of A, plus P of B minus P of A intersection B. Even in this case, when it is disjoint, it's the same formula except that this value is 0. There is no intersection. Does that make it better?
Yes.
All right. Yeah. I'm so sorry about my throat. Okay. So now let me pose this question, and what I would do is probably respect each other's. This thing. You don't have to. You know the answer. That's great. But if someone doesn't know it, I would rather that person tries to answer it. In an experiment involving smoke detectors, an alarm was set off at a college dormitory at 3 a.m. Right, out of 216 residents in the dormitory, 128 slept through the alarms. If one of the residents is randomly chosen, what is the probability that this person did not sleep through the alarm? Can someone try to solve, or can someone walk me through this thing? Probably what I'll just switch to this mode, and if you raise the hand, I'll just ask that question to some who knows the answer. I'll ask that person to raise the hand. If someone knows how to answer the, I see. I cannot see how the hand is. Okay, whoever knows it, please take a stab at it. I cannot manage this one. So. And just other thing is, please do not use ChatGPT or something, because this is we are learning here, right? I use ChatGPT, but only once it is like I just do not understand something. So let's try to learn here. That is more important. Sorry. Any idea what?
It can be the total number of students, that is 216P 128. That is the total number of the combination, that if I can say.
Okay. So what is the information we have got? We have got you know what is the sample space, right? Do you understand what is the sample space?
Yeah.
Right. So sample space is 216 here, right?
Yeah.
And it is saying there is an event which says that this guy, 128 folks slept through it.
Yeah.
So, and you are saying if one of the residents is randomly chosen, what is the probability that this person did not sleep through the alarm? How many people are there who did not sleep through the alarm?
Which is minus 128. Minus 128. 88.
Whatever this value is, if someone can tell me, and please keep your calculators handy because we'll actually require them. So I'm assuming this is somewhere close to 88 or something. Is it 88?
Yeah.
Okay.
38.
Sorry.
88.
Okay. I'll just assume it is 88, right? Let it be the right answer. Okay.
Yes.
So we have to choose from these 88. That is when we'll fulfill this condition. Is this correct?
Mhm.
And how many people are can we choose from total?
260.
216.
So 88 divided by 216 is the probability that when a resident is randomly chosen, the person did not sleep through the alarm. Is this clear to all of you?
Yes.
Okay. This will, trust me, this will get very complicated very, very fast. And the faster it gets complicated, the better it is for us, because we will go to the business end of it very, very soon. Okay. So now, can you read this text? Is it readable to you, or should I zoom it?
Yeah, we can read it. Organization, right?
Okay, yeah. So I'll read it. the organization that employs, and by the way, I am following a book called this is called uh, mm, Introduction to Statistics. I think it's Introduction to Statistics. I have it open actually, but I think Introduction to Statistics. And I will buy Sheldon Ross. This guy is like the ultimate guy in probability and statistics. So I will probably starting from the third session or so. I will go to the text that is prescribed to you by Professor Shovan Chaudhary. But I believe these examples are very well explained in this text. So if you want it, I can forward the PDF of it to you folks, and you can try to solve it. I'm using much of the solved problems; they are more than enough for you. I try to solve the exercises, and they become very very hectic, and you don't really require that kind of a for MBA. You do not require that kind of a technical thing expertise. Okay. So the organization that employs Jacobi is organizing a parent-daughter dinner for those employees having at least one daughter. Each of those employees is asked to attend along with the with one of his or her daughters. If Jacobi is probably Jacobi is known to have two children, what is the conditional probability that they are both girls, given that Jacobi is invited to the dinner? Assume the sample space to be GG, GB, BG, BB, right? And all these outcomes. See, this is very important, right? Can someone explain me what is the meaning of this one, this particular line?
That it is a pair.
Probability is same for all.
Yes.
three outcomes.
Yes, equally likely basically means everyone has equal probability. So when we roll a dice, P of 1 getting 1 is 1 by 6, which is same as P of 2, which is same as P of 3, so on P of 6, right? So that is equally likely event. Heads and tails and all those examples. But there is a very important thing because it determines a lot of outcome in our experiments that we do. So you have to be familiar with what it really means, the equally likely thing. Okay. So now can we solve this?
It would be 3 by 4 because in three scenarios, if he has at least one girl, right?
Okay, so because I cannot see the screen, I don't mind if you just please, it will take me some time to get familiar with your voices. You can tell out your names multiple times. Who's that?
This is Utkarsh. So
Utkarsh, yeah.
since the condition that he can be invited would be a girl, at least one girl, right?
Mhm.
And in the out of 4 outcomes, 3 are the favorable. Even if he has 2 girls or 1 girl, he would be invited to the party.
Okay, so you are
That's
saying
how
it's,
it will be.
yeah, you are saying it's 3 by 4. So anyone has any other thoughts on this?
This is summary. It is 1 by 4, is it? Because they are asking for the conditional probability that they are both the girls, given that Toby is invited to the dinner.
Okay, awesome. Nice thought. You read the term conditional probability, which is fantastic. Any other thoughts?
Hi, this is Logan. I quite didn't understand what does it mean by conditional probability that they are both girls.
Okay.
What is that?
Fantastic. Okay, so let me now introduce this, and then we'll solve this problem, right? Conditional probability says that what is the probability of an event given another event has happened? Okay. What it means is, let's assume that we are rolling a dice, right? So we are rolling 2 dice. Okay, so we have how many pairs will we get, anyone, if we are rolling 2?
36.
36.
36, right? Fantastic. So now, my question to you is, I am saying B is an event which says you have landed, you have, no, I'm going about it in the wrong way. Let's say A. First, let me define A. What is A? I'm saying A is an event where the sum is even. Sum is even. Okay, and B is you have landed 1 in the first row or the first die. I'm sorry about my handwriting, but are you all following what I'm saying?
Yes.
Yes.
Right.
Yes.
So there are two events. So I'm saying that sum is even, and I'm saying that you have landed a 1 in the first row. So now, how many? If I just ask you the question, what is P of? Ignore B for now. I'm just asking you P of A, which is sum is even. Okay. Then can you tell me how many cases will be there?
18.
Perhaps not 18. You get the gist right, but there are also odd numbers when they are added together. They also give you even number, right? So it is not just exactly the half. So it's every
24.
every odd pair that you have. So basically, 1 1, 1 3, 1 5, and there are 3 over there in this. There are probably you could be right. I'm not sure actually. Let's see. 2 2, 2 4, 2 6, 3 here, and then such.
In every row is this.
Every long. So you are right. I'm so sorry about that. So it is 18, right? So P of A is 18 out of how many?
But this is
36.
36.
Okay. Now let's look at P of B. You have landed 1 in the first row. So P of B is
6.
6 out of
6 out of 36, right? So without intuitively, without looking at the formula, what really that P of A given B means, can you tell me how many cases the sum is even when you have landed a 1 in the first row in this one?
3.
3,
Three.
right? So 3 is the number of things that you have landed out of 36, and that makes it 1 by 12. Sorry, right? And let's just see that it is 18 out of 36 divided by 6 out of 36. I'm so sorry. This is there is something I missed. P of A given B. I missed something. 1 second. So P of A given B, the formula is this. P of A given B is given by P of A intersection B into P of B. Okay, this is the formula that is there. Where it is coming from, this will be heavily used in Bayes theorem, is P of A P of P of A is equal to P of A intersection B. If this is P of B, this is P of A intersection B is this. Yes, I'm so sorry. The formula is this: P of A intersection B is equal to P of A given B divided by P of B. Which is fantastic. Please pay some attention here. I said P of A intersection B is, and I'll come back to this in just 1 second, but this is very, very important, ultra important. P of A intersection B is equal to conditional probability of P of A given B by P of B. But can we not write this P of A intersection B as P of B intersection? Right?
Yes.
And that makes it, I mean, there is nothing really here. It also means this is P of B intersection B given A divided by P of A. Okay, and this is where Bayes theorem comes in, but we'll expand on it in very detail. But keep this at the back of your mind. If you don't get it, it's all right, completely all right. So that's the formula. So P of A intersection B, what was the value that we got P of A intersection B as?
1 by 12.
P of A intersection B is where did we get that?
3 by 36.
No. That is not P of A intersection B. That is actual thing. P of A given B.
Hello.
Yeah.
Can I interject you for a second?
Yeah, sure.
Isn't the formula P of A given B, P of A intersection B divided by P of B? Or am I mistaken? Just ask.
Yes.
You are right. I'm so sorry. Yeah, it
Not-
is. It is, and but it will yield the same. Yeah, you're right. I'm
Right.
sorry. I'm sorry about that. So that is where I was thinking I'm doing something wrong here. And I'm so sorry. So let me just write it down again. So P of uh, A given B is equal to P of A intersection B divided. Sorry, what happened? Divided by P of B. Right. In this case, we have chosen that uh, here we have chosen the events. First of all, did it become clear to you that what was the difference between P of A given B versus P of A in this case? How did we arrive at P of A as 18/36 and P of A given B as 1/12?
This is actually, I just didn't follow P of A. I did follow P of B.
Okay. So P of B is what is a event that what is the definition for event B? Event B is saying that you have landed one in the first roll, and that is all the dice roll over here. Is that correct? You have got one as the first roll, so you have got 1 1. You have got 1 2. You have got.
I'm referring to P of A, which I didn't understand.
Oh, you did not understand P of A. P of A is just saying sum is even of the two dice roll.
Okay, it has to be even. Got it.
It has to be even. So you can get 1 1, you can get 2 2, you can get 2 4, so on and so forth, right?
Yeah.
Right. So that is we established that there are 18 such ways to get that. 18 out of 36. And P of B, essentially, we are choosing from that. The idea is we know from this that you are getting only 1 1. Sorry, not P. You have got 1 1, you have got 1 3, and you have got 1 5. These are the only three things that qualify. Is this correct?
Yes.
Right. So these three out of the sample space, which is the new sample space where one has landed, is 6 actually. And B intersection D. Okay, let us use a formula. I am sorry, I probably have confused you, and actually I went wrong and I confused you. So let me just do it under once more. Are we clear on P of A? The number of values that we got for P of A over here.
Yeah, we are good.
We are good here, right? Now we want to see P of A intersection B. This is what we want to know, right? Because P of A intersection, because the definition of this is P of A given B is equal to P of A intersection B divided by P of B. And P of A intersection B is what? Sum is even, and you have landed 1 on this thing, right? How many are those?
3.
3. Okay. And P of B is actually it is 3 out of the entire thing if we do, but I'll come back to the formula later. And what is P of B? P of B is you have landed 1 in the first roll,
1 by 6.
and that is 6. That is 6, right? Not 1 by 6. You mean 6 by 6, 36.
Yeah, that's why in the beginning I told you the P intersection B is 1 by 12 and P of B is 1 by
Yeah. So yeah, so these two cancel each other, and that is why it is 1 by 2. Correct? Okay. So conditional probability is essentially Now let us solve this problem. This is conditional probability, and most of our questions that we'll be solving will be around conditional probability and Bayes theorem. Okay. So now this guy is saying that Jacobi is organizing a parent-daughter dinner for those employees who have at least one daughter. Okay, fine. Each of those employees is asked to attend along with one of his or her daughters. If Jacobi is known to have two children, what is the conditional probability that they are both girls, given that Jacobi is invited to the dinner? Okay. So first of all, what is the this is P of two girls given Jacobi is invited to dinner, right? So in what cases will Jacobi be invited? Will he be invited for this case?
No.
No.
Right? So total number of cases are reduced to what is sample space now? Reduced to what? These three.
Three.
Okay. And in that, what is in how many cases has he got two girls?
One case.
One case. So this is the conditional probability. 1/3. So someone had mentioned 3/4. Sorry, someone had mentioned 3/4 and someone had mentioned 1/4. It is actually 1/4 over 3/4. The 3/4 is the sample space, and 1/4 is the actual the quantity that will be picked up from this particular case will be picked up. Does it make it? I honestly, it will get clear only once we have got about 10 to 15 examples. But do you get a hint of idea as to how the question was
And
different?
can you please come again? How the first one, like the two girl, the 3/4.
Okay,
So
I will.
1/4
Sure.
is-
There are two ways. There are multiple ways to solve a conditional probability. It's quite free also, but let me just stick to one particular thing. So they are saying that what is the conditional probability that both the girls are both are girls, given that Jacobi is invited to the dinner. So first of all, we have established that Jacobi is invited to dinner. Is that correct?
Yes.
And
Yes.
in how many conditions will he be invited to dinners?
3/4.
Is this correct?
3/4.
He will not be invited in this case. Right? And now, how many conditions how many cases are there when he has got two girls out of the entire sample space?
1/4.
1/4.
So it is P of A intersection B again by P of B, right? And P of A intersection B is that he is invited to the dinner, as well as he has he has got two girls. So that is 1/4, and the total number of cases in which he will be invited would be 3/4, and that is why it is 1/3.
Got it.
Okay. We will. Okay. I will not ask you whether it's clear or not, because I know that it won't be clear right now. It will become clear gradually. Now, let's solve this one. This is very easy one actually, but it lays some foundation. Suppose that two people are randomly chosen from a group of 4 women and 6 men. What is the probability that both are women? Any thoughts?
1/10 into 1/2. Will it be like that?
You are very close. And it's not 1/10. So you can. Let me know if you do not understand these things. So you can choose. What is the probability that both are women, right? So both are women, meaning you can choose only from this group. You cannot choose from 6 men, right? Is that correct?
So 4C2 by 10C2.
Awesome. Yes. If you are not familiar with this terminology, please let me know. Then I will explain this terminology. And
Who will help us with this?
Yeah, please help.
okay, sure. So I will probably backtrack. Let's assume that you have to choose. You have 4 females, and help me with this because I'm very lazy with imagination. Give me some names. 4 women names, probably. Okay, let's say Rita, Give me some 4 names, right? Tina.
Ritu.
Sorry, I
You can
could
go with A, B, C, D.
not. It just makes it easier for So give me some Somali. Okay. Now we are saying that I have to choose 2 women amongst these 4, right? And how many ways can I do that? So first, can I imagine this to be something like this? Can I choose Rita and Tina? Is that okay? Fair?
Yeah.
Can I choose Rita and Neeti? Yes, I can choose Rita and Sonali, right? Right here, I've got. I can choose these many. Then I can choose her and her. I can choose her and her, and I can choose her and her. And the order does not matter. That is very important, right? Order does not matter. So I can choose them. The first place I can choose them in 4 ways. Is this clear? The first person I can choose in 4 ways because I could have picked up anyone, Rita, Tina, Niti, or Sonali, right? And once I've chosen Rita, I cannot choose her again, right? So the second person I can choose in 3 ways, correct? Now,
Correct.
now because the order does not matter, I could have chosen Tina first and then Rita second, right? And 4C2 is basically that. 4C2 is basically, I hope I remember correct, factorial 4 by factorial 4 minus 2 into factorial 2. Is that correct?
Yeah.
Yes.
Yes.
Okay, I hope I'm correct here. Okay, so that's a formula. It's basically NC2, NCR is equal to factorial n by factorial r into factorial n minus r. That is a formula. Um, and so, no, there's no factorial r here.
Yeah.
There is no factorial r. There is factorial n by factorial n minus r, right?
Yeah.
Yeah. So, so this is not there. So now 4 choose 2 is basically 4 into 3 into 2 into 1 divided by 2 into 1 because 4 minus 2 is 2. So 4 into 2 into 2 minus 1. And because these two get cancelled, right, it is actually factorial r is there. It is there. Can someone please verify this one? I think it is there. Because the order does not matter. It is there. These two get cancelled and the formula becomes 4 into 3 by 2 into 1. Likewise, for 10C2, it becomes 10 into 9 divided by 2 into 1. And these 2 into 1 and this.
So I'm sorry to interrupt.
Yeah.
NCR would be not the formula would be factorial n by factorial r into n minus r into.
That's what I'm saying. It is there.
Yeah.
Yeah. That's what I said. I mean, the moment I started working with it, I realized that it is there. So it is there. So someone asked me. I mean, I think it is not clear to someone who about how combinatorial. Yes, how this works. So the formula is very simple, and let me just spend 2 or 3 minutes on this one so that this becomes clear to that lady. The formula is this, right? For whenever you have NCR, n choose, we call it n choose k. So or n choose r, NCR. Okay. The formula is factorial n by factorial r into factorial n minus r. And what it really means is, if you take, say, 5C2, then you just take, you write 5 into 4, only two numbers from 5 in the decreasing order, and just divide it by 2 into 1. Why is this so? Because use this formula. So who had asked me that question to explain this part? Someone had asked me to explain NCR, the 4 choose 2 kind of a thing. Someone, who was that? Some girl had asked me.
Tina.
Yeah, Tina. So can you now, n is 5 and r is 2. Can you walk me through this formula now? Now n is 5, r is 2. So can you apply this formula?
5 factorial, that is 5 into 4 into 3 into 1. Divided by 5 minus 2. That is like 3 factorial. In So there are two formulas that you have written. On the first line, you have written actually 4 factorial divided by 4 minus 2 factorial, and the second one you have written n factorial divided by r factorial into n minus r factorial. Which one holds good?
Okay, so sorry about that. This is incorrect. This is correct, right?
Mhm.
So you have after this you have factorial 2 also, right?
Factorial, yeah,
And this gets cancelled,
yeah.
right? So all you have to do is you note the top figure, you note the bottom figure, and you just write that many numbers over here and the factorial of that number. Okay, so here you can choose out of the how many. Okay, so the question is, what is the probability that both are women? For both of them to be women, you can choose 2 women from a group of 4 women in 4 choose 2 ways. And how many total people are there?
10.
10. 4 plus 6. Because that's a sample space, right? So you can choose from 10 people in 10C 2 ways. And the answer is 4 into 4 into 3 divided by 10 into 9. This is 3, and so it is 4 by 30 or 2 by 15 is the answer. That both are women. Now, what is the next question? What is the probability that one is a woman, the other is a man? This is more interesting. What is the probability that one?
4C1 into 6C1 divided by 10C2.
Okay, wait a second. Who answered that?
4C1
Okay,
into 4C into 6C1
okay,
divided by 10C2.
okay. How many of you agree with that?
Yes.
Okay. The problem here is you do not know whether, in this case, it does not matter whether the woman was chosen first or man was chosen first, right? Is that clear? Right? So there is a bit of a difference here, right? So basically, this can be solved in 2 different ways. One way is that you choose P of woman first and then male second, plus P of male second and women first. Sorry, male first and women second. What am I doing? Right? So there are 2 cases here. Or what you can do is you can also say, I'm choosing a woman and a man, which means my sample space or my choice cannot have both women and both men. And I cannot have one. So basically 1 minus P of male and P of women. Both are equal. Is this clear?
If you don't mind,
Yeah.
can you just repeat the formula?
Okay. So the probability that one is a woman and the other is a man, we are choosing 2 people, and it can be women, it can be women, it can be man-women, and it can be man-man, right? If we choose 2 people. Is that correct?
Yes.
And we are saying we cannot choose man and man and women.
Right.
And total probability is always 1,
10 or 1.
right?
Wow.
So 1 minus probability of both are men and minus probability of both are women. We just calculated that what is the probability that both are women? We just calculated this, right? It was probably 2 by 15, right?
Correct.
So we will calculate now the probability that both are men. And both are men, what is similarly, just like we did it for women, what is the probability that both are women?
6C2 by 10C2.
Good. 6C2 by 10C2. Does everyone agree with this one?
Yes.
Okay, so 6 into 5 divided by 10 into 9. And 5, 2 goes into. So this is 6 by 18, which is basically 1 by 3. Is that correct?
Yes.
Okay, so 1 by 3. And we have 1 minus 1 by 3 minus P of V
2 by 15.
by 2 by 15. So this becomes uh, 5 by 15. This one. 1 minus 5 by 15 minus 2 by 15 makes it 1 minus 7 by 15. That makes it 8 by 15. Is that correct? Any questions here?
So Anup, how did you calculate the 6C2 by 10C2? You solved it by 6 into 5 upon 10 into 9. How did you calculate that?
You're talking about which part over here? This one?
Yeah. 6C2 upon 10C2. How did you solve it that way?
Because let's spend one some time once more on this one. When Tina was it? When Tina was asking the same question, what I had mentioned was use this formula, right? So what you have is NCR is nothing but factorial n by factorial n minus r and into factorial r,
Yeah.
right? So now when you have something like let's say 6C2, we'll apply the same thing. Then this becomes factorial 6 by factorial 4 into factorial 2, right?
Okay.
And factorial 4 will take away the 4 items here,
Get that. Perfect.
right? So it becomes 6 into 5 divided by 2 into 1.
Factorial is common both the things, so you cancel them out.
Exactly. And because factorial 2 is common in the numerator and denominator, so this I don't even have to write this one. Right?
Makes sense.
Is this clear?
Mhm.
Okay. So are we clear with this particular problem? Problem number where we found the probabilities for both men and women.
So this we did by, negating the women and men.
Yes, and that's a very useful principle. That's a very useful principle. But you can do it with the other principle also, where you say, I will choose men first, and then female. Sorry. Second, there is a very important principle there, which I should mention. P of A and B is equal to, we saw that, right? P of A given B into P of B. We saw that, right? As a formula. If they both are independent, not disjoint, I'm talking about independence, right? Then P of A, what it means, it's saying that A and B are independent. Then do you think occurrence of B will affect A?
No.
It will not, right? So for not mutually exclusive, for independent events, P of A given B is same as P of A. This is very important, very important formula, which people often, well, some of the mistakes, unless you practice, you're going to make in this one also. In this one, if they are independent, then P of A given B is same as P of A.
Into P of B, right?
No, there is no. I'm just talking about this term.
Sure, okay. Yes.
Anup, can you give us an example for that?
It will come. Give me just the next example is talking about A and B independence. You're just 2 minutes ahead of me. Okay. So now, but are we clear with this particular example?
I just one doubt, Anu.
Yeah.
So you mentioned we shall be considering the man first, then second women, then women first and man second.
Yeah.
Why would we do that if the order is not required?
Because the order may not be required, but you're choosing. The reason is because there's something called multiplication rule, wherein you get to choose. You do not get to choose when you say 10C2 and when you say 6C1, right? Because the order does not matter, you are you have to consider that this woman could have been picked second also, which you are ignoring actually in this case. Precisely because order does not matter. You have to make sure that if you chose the man first, okay. So here's a question for you. But you can do this as a part of homework also for the next session, wherein I can work it this out. But I insist that you do the other approach and then match the notes. You will understand the concept that I'm trying to say. Will that be okay?
Sure thing, yes.
Yeah. So I'll we'll start with this particular problem in the next session. When we do it, solve it the other way. I mean, I can do it right away, but then I don't want to kind of spoon feed on that part. Okay, let's go to the next one. Suppose that we roll a pair of fair dice so that each of these 36 possible outcomes is equally likely. Let A denote the event that the first die lands on 3, and let B be the event the sum of dice is 8. I think we just solved something very similar, right? So, are A and B independent? So, what do we? Okay, can someone walk me through this example so that we can see if what are the 3 events?
No, A is like 1 is 3.
First is 3, right? So, how many of those will be there? Is this correct?
Yes.
6 by 36.
Okay.
1 by 36.
And B is sum of.
No, it's not.
1 by 6.
Which one? Which one are you saying? 1 by 6?
And P of B.
P of B is 1 by 7. Is that true? Let's say 1. The answer will be 2. Okay, let's just see this. The sum is this. So 2, 6, and then nothing else.
3,
And you get
3, 5.
And then you have 4, 4. You have 5, 3, and you have 6, 2.
Yes. 5 by 36.
So it is 5 by 36. Correct. And C with the event that the sum of the dice is 7. Okay. So P of C, what would be the cases? 1, 6, 2, 5, 3, 4, 4, 3.
5 to 6 12.
It would be 6 by 36.
Yes.
6 by 36.
This is one of the most beautiful examples in Sheldon Rose, by the way. How something is independent. How
Okay, can we P of A for I missed that actually.
sorry.
P of A, can you explain me for once?
P of A is first die lands on 3, so you have you have 3, 1, 3, 2, 3, 3.
Alright, I understood that.
Right, so 3, 6. There are only going to be 6 such things. So 6 by 36, right?
Yes.
Now, are A and B independent? So P of I just told you that there is for independence P of A intersection B is going to be P of A into P of B, right? This is what I told you if they are independent, right?
Yes.
Okay. So now, can we apply this? What is P of A intersection B? P of A is this. A is this subclass, right? And B is 3 by 5. 3, 5 is there, correct?
I think we have only 3 by 5 only.
Only 3 by 5, right? Out of how many?
Out
Given?
of, we can say that 36. Because
Yes, exactly. It is. So P of A basically, okay, what is P of A now? P of A is 6 by 36, and what is P of B? 5 by 36. Okay. And when we multiply, will it be equal to 1 by that? It won't be, right?
No.
Okay, so they are not independent. But let's see A and C. A is how much? 6 by 36, and C is how much?
Both are 1 by 6, yes.
Both are 1 by 6, right? Please, P of A is 1 by 6. 6 by 36 is 1 by 6. And P of C is also 1 by 6. Yes?
Yeah.
Okay. And how many such cases are there that P of A intersection C happens? This case,
Yes.
Yeah, that is 1 by 6.
right? So 1 by 36.
Yes.
And is it equal to P of A into P of C?
Yes.
Yes.
So please understand that this rots your brain.
Once again, please.
Yeah, I will. This rots your brain, right? That let me wipe it and let me explain this. Can someone lead the explanation so that everyone can join into one to show what we are
I
doing?
did not understand the question. What is like, are A and B independent? Like, what do you mean by
Okay.
that?
So let me first tell. Okay, anyone, what is independence we just established? Independence is basically when the outcome of an event does not change the outcome of something else. Okay, so for example, it's gonna. We saw it very in the beginning that it is going to be a Tuesday and it's going to rain. They are independent events, so it will not, whether it's a Tuesday or not, it will not change whether it will rain or not, kind of a thing, right? So they're independent events that way, right? So now with independent events, we just came back from conditional probability wherein we say P of A given B is equal to P of A into. I'm so sorry, I just wrote it wrong. Let me just put it. I was making the same mistake again. Into P of B. This is the formula for conditional probability. Okay. There was actually one problem that I thought that would explain it in a terms that is easier. Why have I not taken that? Yeah, I'll try to take it the next time and make something easier. Why have I taken that? No, I have not. Is it in my notes? Just checking. I think it is. Yeah, it is. There is a problem that I have in my notes. I'll just tell that, which will make it even easier. The conditional probability. So this is the formula. You have to remember this formula always. This now A intersection B is the area. A intersection B is the area which is defined by this particular part, right? And what we are saying is that this is always equal to P of B given A into P of A, and I'm equalizing these two parts. Whether you say P of A given B into P of B, or you can say P of B given A into P of A. This is basically a weighted probability. What it says is, okay, what is the probability? The probability of B with the weighted probability that B has happened. What is the probability that A has happened? So this is a formula you have to probably wrote. I'm so sorry about that. I mean, there is no other way to explain that, right? Now, what I've said is, if these two are independent, okay, then when P of B happens, it does not affect the happening of P of A at all. In that case, P of A given B simply becomes P of A, because P of B is not the B is not affecting A's outcome. I will probably give an example. This is actually an example. This is a fantastic example. A bit counterintuitive, but what it is saying is that C was the sum, even that the sum of the dice is 7. And the moment sum of the dice was 7, the events became independent. But with the moment the sum of the dice was 8, they were not independent any longer. How do I will try to better my explanation. I understand the issue that you're having. I'll try to better my explanation in the next session on why. I can give an example of what is independence, but I believe this is counterintuitive to you, that why is why are these two independent while A and B are not independent? So allow me one more session to answer that particular question. Okay, but all of you understood how we computed this particular session?
Yes.
Or do we want to redo this part, some part of it?
It would be helpful, sir, like, some concepts we have forgotten. So it would be helpful if, we can brush through it before the next session comes.
So the whole point is, the reason I'm taking this session is because in your next session, your professor is going to teach you this, and you will have a better idea going into that class. And just and just call me Anup. I mean, that's the reason why I think I mentioned it also in the group that I would want to get started with this, so that when professor is talking about it, you are not blank faced, because he will go at a very fast pace. Okay.
So is there any book that just do it like as kids? Sorry, but we need to,
No. So I will share the book that I am following. Okay.
Okay.
I will share that book with you. You can go through that, but please understand that I had spoken to Professor Shovan once, and I told him I was doing problems from Sheldon Ross, and he said that he gives these problems to his PhD students. So I realized that, I mean, I had to spend a lot of time to just understand what the problems were even saying. I can actually, I don't I'm not exaggerating. Give me just 1 second, and I'll show you what I mean, and we'll go back to solving a couple of problems more. Give me just 1 second, please. Where is that? I don't have it. Sorry. Essentially, my worksheet is full with personal notes that I attempted a problem very bad and other things. But so you don't have to. These are the worked out examples in Sheldon Ross. They are more than sufficient, and then we will switch to the problems that your books have, unsolved problems also, and we'll solve them. Because once you have solved these, the concepts will be much simpler for you. Okay. Let's see this. And I think I'll solve 3 more problems before we wind up. I was supposed to wind up 15 minutes back, but that's all right. Each relay in the following circuits will close with probability 0.8. If all relays function independently, what is the probability that a current flows between A and B for the respective circuits? Okay, so what are we saying? Each will take one at a time. The probability of this being closed is 0.8. When it closes, the current flows, right? And the probability that this will close is 0.8. Correct? What is the probability that a current flows between A and B for the respective circuits? So now, what is the probability that current will flow from A to B? Can someone tell me?
0.8 into 0.8, will that be?
It is fantastic, but then you have also just help me with this thing. A and B should be equal to P of A given B
P of B.
into P of B, but whether or not B is open has no consequence on whether A is open, correct?
Yeah.
Okay. So these are independent events. So P of A given B reduces to
P of A into P of B.
just P of A. This reduces to just P of A.
Yeah, right.
Right? And this is P of B. So 0.8 into 0.8 is equal to 0.64. Does this help with your understanding a bit about what the independence really mean? I could not have done that. I could not have used this formula had they not been independent of each other. The opening or closing of B has not B, sorry, the second circuit has nothing to do with the opening and closing of A, and vice versa. Is that part a bit clear?
Yes, sir.
Okay. Just be with me for another 15 minutes. I think we just have 2 more problems that we'll do. I know this is getting a tad bit heavier. And please feel free to ask me or let me know how should I have covered it, because it's my first time. I'm so sorry if I've taken you for a very bad tour. Okay. Now this is in parallel. So the current can flow either this way or it can flow this way, correct?
Yes.
So you need only one of them to be open. So what is the condition?
0.8.
No. What is the condition? In probability terms, what's the condition? How will we call it?
Either of them works for us.
So P of this or, right?
Yeah.
It is not, here it was P of this and,
Yeah.
right? This is or, which is nothing but P of
Union.
A union B. And what's the formula for P of A union B?
P of A plus P of B minus P of A intersection B.
P of A is how much? 0.8
0.8.
plus 0.8 minus, what is P of A
0.6.
intersection B?
0.64.
Yes, we just did that here. Okay, and this is probably someone can help me with what the answer is going to be. I don't have to, I mean, but did you understand this part?
0.04, I think. It should be.
This is 1.6 minus 1.64, probably 9.96 should be.
Okay, yes. 2.96.
I think so. I mean, okay. Is this part clear? Anyone has any questions so far? Is it getting heavier? Shall we stop? Some response will be nice. I can see my, sorry, I cannot see the window where I'm on. I do not know what to say. But let me know if you want to stop. But because the third one is pretty good. But okay, let me stop here. I mean, if everyone wants to, because if it's getting heavier, then we can revisit some concepts again. I will just
Hi.
Yeah.
Prashant here.
Yeah, Prashant.
Yeah, I think let's stop here, and for our next session,
Mhm.
try to build some theoretical foundation, because many of the guys have forgotten. I know that most of them have.
No, I will try to do that. I will definitely try to do that. The problem here is the theoretical foundation. If you can take my word for it, the theoretical foundation will be built now. I just wanted to see how much are you familiar with these things. I'll tell you the reason why I'm saying that. I will just put this one. This is the theoretical foundation for it, and this is in your book also. And I wanted to get you to this particular part. This is the theoretical foundation for Bayes theorem. I'm just what I'm trying to do is I'm trying to give you an intuition. You can see my screen, right?
We can, yes.
Right. This looks very heavy, but it is very, very easy. It becomes easy only when I give you an intuition with the problem solving. Uske pehle na, I'm sorry, I'm breaking into Hindi, but before that, trust me, it is. This is the problem we are solving. This is the from the exercise that it has, right? We are just solving this problem. So before that, the theoretical foundation is very, very meek. But if you want me to solve explain some very basic concepts, please put the questions in, and I will try to cover that also. As I said, this is the first time I'm running something like this, so you will have to pardon my inexperience with it, but I will try to do that. This is the formula that I showed you. That is the formula that you'll be bombarded with in your exam, without working with the too many examples, depending on the professor kind of a thing. Before that,
Tanu, getting similar level of questions in our final exam also.
what I'm assuming is I just went through the book. Yeah, I mean I did it some time back, so I don't remember exactly. But the question that you will get will need you to apply the concepts that we are just discussing in terms of what are the independent events. I'll answer your question in a second, but here's a question: P of A plus P of B. Here's a question for all of you. Please, is equal to say 1.5. Is this true or false?
False. False.
Okay. Anyone who thinks it is true or it can be true?
It can be true.
When?
If they are independent in that scenario.
No. No. So here you may want to use ChatGPT or something to make sure that you understand what is
See, in the
a-
previous question, Anup, it was 0.8 and 0.8, so the sum is 1.6.
Mhm. And I'll just come to that.
I think we can't exceed one. Probability can't
Yeah. Probability cannot be exceeded.
exceed
It
one.
is sum of two probability. It's not.
I'm not saying probability. I'm just saying P of A plus P of B. Can it be say greater than 1? That is my question,
Can be.
right? And the answer is something which is where will come. It can be. But let's understand what it means. Independence, mutually exclusive. So these are the things you will have to make sure that you understand the concept. And I will, this is a good pointer for me to explain these concepts in bit detail in the next session. If they are not disjoint, that means that there is an area of this, right? Disjoint would mean what? This and this,
Two complete different shapes.
correct? And here the probabilities cannot exceed. Some of the probabilities cannot exceed 1. But in disjoint, what you have done is you have added this area twice. Do you see the problem that what I initially referred to?
Mhm.
P of A union B for non-disjoint is P of A plus P of B minus P of A intersection B, right?
Yes.
This cannot exceed 1,
Mhm.
but this can, because you have not subtracted once more. Do you see where I'm getting with this? See,
Yes.
they are not disjoint, right? Had it been disjoint, then this cannot exceed 1. Because this would be
Okay.
0.
Exactly. Mhm.
Understand?
Mhm.
Okay. So some of the key takeaways from today's this thing and point taken, I will try to keep it a little bit. I will try to talk about independence and mutually exclusive a little bit more, and then take through the Bayes theorem, which is the most important theorem, which is what you'll be using throughout. It sets there. It is useful in regression, in Bayesian statistics, and everywhere. We'll build that. So that is that. Any questions so far?
Is there any connection? Yeah, I do have one.
Yeah.
So is there any connection between disjoint and independence of the property?
Yes, independent is very different from mutually exclusive, right? So, um, independence basically says if an event has happened or is happening, it will not affect another event. We saw that in the case of the circuit switch being open, it or close. I can close I mean, let's call them circuit breakers, circuit breaker 1 and circuit breaker 2. Then I could have closed circuit breaker 1 without affecting CB2, right? And vice versa, isn't it? Those are independent events. Okay. Mutually exclusive says if I happen, then you cannot happen. Basically, if I go to office, I cannot be at home. Probability of me going to the office is let's say 0.6, and probability of me not going to the office is then obviously 0.4. But if I go to the office, then I will not be at the home. So those are mutually exclusive events, right? One basically says second cannot happen, right? So there is no P of A intersection B in that case.
So
Correct?
mutually exclusive.
Yeah. Okay.